All right. Hello and welcome into my channel. Greetings. Happy Friday. We're going to do a math live stream here. And yeah, I hope everyone's doing well. I'm going to go ahead and get into it. I am working on solving systems of linear equations using matrices. And I am applying a method called Gauss-Jordan Elimination. And so I'm going to start at a system of three equations in three variables. So I picked one out, and yeah, we'll just get into it. And yeah, happy Friday. So I was hoping to go ahead and look at this system and maybe spend some time today, but I didn't get a chance to. So it's fine, because this is the time that I've allotted for math. And I'm just showing up every day and trying to work on the math diligently so that maybe one day I can be good at presenting. And so I really feel like I'm not there yet. And so, yeah, I got to show up and put in the groundwork. So I've got this system, so let's just write it out and look at it. All right. So we have this one. It's x plus z equals 3. And we have, let's see, 2y minus 2z, and that equals -4. And then I have a y minus 2z equal 5. And it says that there is a unique solution, and so we should be able to find it. And so although it looks like only two variables, we actually have three we're dealing with. So I want to show you how you would set up the matrices on this one. And it's not important that we get it solved today, but that would be awesome if we did. And yeah, all right, I'm just making sure that I got it right. So I have x plus z 3, and I have 2y minus 2z equal -4, and we have a y minus 2z equal 5. Okay, very good. Just double checking I wrote it down correctly. And here's how you would set up your, so what we're doing is we're going to create a 3x3 matrix. So it's a matrix consisting of 3 rows and 3 columns. And then we're going to augment it with the constant matrix. And so it's going to actually create a 3x4 matrix. And we'll go ahead and get into it. So when you have to make sure that it's set up correctly. So here's what you would do. So you would list your x. So all your x values you want to appear in this first column right here. And so you notice in these second two equations, there's not x. Well, what you're going to do is you're just going to use 0 as a placeholder. So when I write this system, I'm going to have 1. And again, I'm just listing my coefficients. And there's this hidden 1. So if your variable looks like it doesn't have a coefficient, it does have a coefficient. It's just 1. So we've got 1, and then y is 0, and then z is also 1. And we don't have an x here, so we have to go ahead and have a placeholder. So we're going to say 0, 2, -2. And then here we don't have an x, so we're going to have another 0. We have a y, which is 1. And we have a -2 for z. So that I have all of the x values, all the y values, and all the z values lined up here. Let's see if we can get that a little bit neater. And then what I'm going to do is I'm going to augment it with the constants. So we've got the coefficients and the constants. So it's 3, -4, 5. All right, very good. So we have this matrix, and again, we're going to be employing this concept called the identity matrix. And what the identity matrix is it is a matrix consisting rather of ones and zeros and in reduced echelon form. So here is we'll go ahead and as a reminder, we'll just list that identity matrix, and we can put that in here. And this is what it looks like for a 3 by 3. We have ones along the diagonal, and then everything else is 0. Okay. So we have a lot of ones and zeros here already. And so if you notice that this is a 1, we want to make this a 0. This is 2, we want to make this a 0. And then this is a 1. We'll either swap these two rows out and make this a 1. I think that's probably my first step right there, is to swap those rows out. Let's do that first. And again, there is no one way to solve this. There's multiple ways. There are many, many ways to solve this. So it just comes down to unique, creative experience, all that good stuff. So I'm going to go ahead and just recopy this matrix. My first step that I chose to do is go ahead and I don't know if this will work out. Again, the goal is to solve it in as least amount of steps as possible. So we've got 0, 1, -2, 5. We're just swapping out the rows. We'll just say swap. I'm trying to keep consistent with my notes. So we have 0, 2, -2, -4. And again, we're employing these operations, row operations. They're called elementary row operations that you perform on your matrices. And eventually we want this right here, this 3 by 3, we want it to look like this. So looks like by swapping those two out, I already have these two. I have this column complete, so I'm not going to mess with this column. Once I have a 0, I'm going to try to do whatever it is the next step to maintain that 0. So I don't want to change the zeros around any. So I want to make this one a 0 by performing some operation. So what I'm going to do, I think, let's just think about it. Let me just take a step back and kind of, an ounce in time will save 9. So we want to make sure that we want to make sure that whatever we're doing, we're preserving the integrity of the matrix. So far, we don't want to make more steps. So I think, just look for a second and see if anything stands out. I'm probably thinking that the first step to do is probably multiply this one by a -2 and add it to row. Let's see if we can multiply this by -2, add it to this row, and replace. We don't want to replace row 2 yet. We'll probably replace row 3. So let's do that. Let's see what happens. All right, so I'm going to go ahead and say, what did I say? I'm going to do -2, row 2, plus row 3, and we'll replace row 3. Let's see if I can fit it in here. It is important for me to conserve the board because sometimes these matrices, especially the 3 by 3s and up, they take many steps. And so hopefully this one is not too bad. So we're going to go ahead and just write down row 1, repeating it. So it's 1, 0, 1, 3. And then rather than writing row 2, we're going to multiply it by -2 and rewrite it. So we've got -2 times 0 is 0. -2 times 1 is -2. -2 times -2 is +4. And -2 times 5 is -10. And again, I'm just going to, I'm replacing row, yeah, okay. So we've multiplied everything by a negative, and now I need to add row 2 to row 3, and we're going to write the new value here. So we've got 0 plus 0 is 0. -2 plus 2 is 0. A 4 plus a -2 is 2. And then -4 plus a -10 is -14. All right. So I've almost got this column. So I'm going to go and leave that -2 there, leave that 2 there. What I need to do is I need to make both of these values right here a 0, if I can somehow. So we'll multiply row 1 by -4. We'll add it to row 2 and replace row 2. Let's do that. So we're going to say -4 row 1 times row 1, and we'll say plus row 2, and then we'll replace row 2. That's what we're going to do. Okay, let's see what happens. All right, so I'm going to multiply -4 times row 1. And so that's going to be -4 times 1 is -4. -4 times 0 is 0. -4 times 1 is -4. -4 times 3 is -12. And we have row 2. We're going to add, so let's just do it now. We have, hang on a second, do I really do that? Because if I add that to row 2 and I replace row 2, it's not going to be 0 anymore. So 0 plus 1 is 0. That's going to change that one too. Yuck. All right, let's just see what happens. So we're going to go ahead and add 0 plus -4 is 4. Negative, let's see. Zero. So we've got -4 plus 0 is -4. 0 minus -2 is -2. -4 plus 4 is 0. And negative 12 minus 10 is negative 22. And then we have 0, 0, 2, negative 14. Okay. And what I really want to do, okay, so I have that in 0. I need to make this one 0 as well, if I can. So the only way I can do that is if I multiply root 3 now. I multiply root 3 by a negative 2. And we're going to add that to row 1. So it's like negative 2 row 3 plus row 1. And then we'll have to replace row 1. So let's do that. So we'll say we're going to replace row 1, and we'll start out by writing. We'll go ahead and write in row 2. Negative 4, negative 2, 0, negative 22. And then we're going to multiply this scalar through. So we'll write row 3 next. Negative 2 times 0 is 0. 0. And then negative 2 times 2 is negative 4. Negative 2 times negative 14 is positive 28. And I'm just trying to be very careful because I don't want to make a single mistake. And that is the real challenge for me personally, because I do make a lot of mistakes. And I'm working on that. I'm trying to be more careful. So we have this one here, row 3 plus row 1. So we've got 0 plus a negative 4 is negative 4. And then we have 0 plus 0 is 0. And then we have negative 4 minus 4 is negative 8. And then we have 28 minus 12 is 16. I think I'm confident on that. Let's see what else we got to do. All right, what would be the next best step? I think that's the problem with doing math by yourself. It's like you're stuck in your own head, and there is strength in numbers. And so if I had a bunch of people helping me with math, that would be better. But honestly, this is good. Like, I'm happy because I'm working on my skills. So it's Friday and I heart math, so it's fine. All right. I really need for this position and this position. So I only have 2 positions left. So I really gotta be careful. And if I do, I can solve it pretty quick, I think. So I need this one to be 0. So if I multiply by a negative 1, multiply that by a negative 1 and add to row 1, then I can make that position 0. I'll have to replace row 2, I think. All right. Negative 1 times row 2 plus row 1. And here's where I'm just trying to decide, do I want to replace row 1 or row 2? So just trying to do the math in my head real quick. So that's going to be 0. That'll be -2. And then I think that it will affect this 0 if I replace row 2 with -8, which will defeat the purpose of what I just did. Oh, goodness. If I add it, can I possibly make this 0 first? That way, when I add them. All right, so what we have to do is we're going to multiply. We'll multiply row 3 by -2, and that'll give me a +8. And I can add it. Let's try that. All right, so we're going to do -2. -2 row 3 plus row 2, row 1 rather, and then we'll replace. So we'll do that. That'll become 0. That'll stay the same. Okay, we're gonna replace row 1. I think that's the best thing to do. All right. So we've got 0, 0. +8. And then -2 times 28 is 56. -56. And then we said we're going to add it to row 1 and replace row 1. So we've got 0 minus 4 is -4. 0 plus 0 is 0. And then 8 minus 8 is 0. And we've got a -56 plus 16 is 40. Oh, okay, right. And then we'll just rewrite it into row 2, -4, -2, 0, -22. All right, I think we're almost there. Really, all we have to do is figure out this position right here. And then I'll be good. So we have to multiply row 1 by -1 now, like I was going to do before. So we'll say negative row 1 plus row 2 and we're going to have to replace row 2. Let's see if that helps. All right, so we got it. So we got -1 times 4 is 4. -1 times 0 is 0. And then -1 times 40 is -40. And we're adding it to row 2. So we've got 4 minus 4 is 0. We have 0 minus 2 is -2. We have 0 plus 0 is 0. And we have -22 and -40. Okay, I think that's correct. That's going to be 62, -62. Let's double check. So we have -1 times row 1 is here. And we're adding it to row 2. 0, -2, 0, and 40 and 22, 62. Okay. And then we're just going to recopy the row 3. 0, 0, 8, -56. All right. So we have all of our values in place. So now we should be able to just simply multiply our scalars and get our solution. So we're employing this method called a reciprocal. And concept of reciprocal, when you multiply a number by its reciprocal, you always get a product of 1. And that's the beauty of the reciprocal. So I can go ahead and multiply row 1 by 1/4. Row 2, reciprocal is -1/2. And I have 8's reciprocal is 1/8. And we'll just do that all in one step right here. So 1/4 times 4 is 1. We got 0. Anything multiplied by 0 is equal to the quantity 0. And then 1/4 of -40 is -10. And then this one, we have 0. So we have a 1. That's a 0. And then I have half of 62 is 31. And that'll be negative. All right. So I have 0, 0, 1. And then 1/8 times 56 negative is -7. Because 7 times 8 is 56. So we should have solved this system, and I hope that we did it correctly. I have not verified it. A system with 3 unknowns is exists in 3-dimensional space. So in the Cartesian coordinate system, there's actually there's a third axis. It's a z-axis. And they don't really talk about it until like later on in math, but it kind of comes out. It's like this. So if you were going to try to graph something in 3D space, you have your y and your x, and then you kind of got like this z thing going on here. So you've got x, y, and then you have a z. So if you were going to locate, it still works the same way where you have a positive direction and a negative direction. Positive, positive, negative, negative. So then you would just say x -10, which we would say right here. And then -31 with y would be all the way down here somewhere. And then the z would be -7, which would be in here somewhere. Anyway, it's a little bit more complicated to graph in 3D. What I want to do is I want to see if the solution is in the back of the book. I forgot to look, so hopefully it is. And let's see, that was 1.1, that was C. I need to make sure that next time I get a solution, it's actually there, which is fine. It's part of the learning process for me. And I have to learn the hard way, unfortunately. It's reality. So, 10C. And is that really 1.1? Yeah, 1.1, 10C. It says x equals +10, y equals -9, and z equals 7, -7. All right, so I have these two values wrong. I must have made a mistake in there somewhere. Okay, so on a Friday, I don't think I have, unless there's something, I kind of did that fast, I did mental math, so, this would not be, I mean, it's success because I showed up today and I tried. However, I think that the only value that is correct is Z. So if I were able to solve this by matrices, which, well, what we can do is we can go ahead and plug that one solution into our regular system and verify. So we have, since we have Z, we can go ahead and say, use this one right here to figure out why Y is. So we'll go all the way here and just fill it to board and finish. So we'll have to just go back to algebra since I have Y minus 2Z equal 5 and Z equal -7 according to my matrix. So we'll go ahead and say Y minus 2 times -7 equal 5. So Y is going to equal, let's see, 2 times 7 is 14, plus 14 is going to equal 5. So we're going to subtract 14 from both sides. Y equals, looks like 14 and 5 is -9. So that's, Y is not correct. So this is correct, this is not correct. And then this one is not correct. So since we have Y and Z, circle those, we can figure out what X is. We'll have to use the first equation because that's the only equation involving X. And what I will do is I will, since that I wasn't able to solve it using matrices, I will go and resolve it in my spare time now. And I'll come back on Monday and we'll start here. But let's go ahead and figure it out. So we have X plus Z equals 3. And so we can use that value for Z again to figure out X. So I have X minus 7 equals 3. So adding 7 to both sides, you get X equal 10. So here is our solution. However, I don't feel successful because I made a mistake in the matrices somewhere, and I just have to try it again. If at first you don't succeed, try it again. All right, and so we have -7. All right, perfect. So, over 30 minutes in, I think that we'll go ahead and call it good. And I'll just do a little doodle, happy little doodle. I'll give him some hair. All right, there we go. All right, so we'll go ahead and call it good there. And yeah, go ahead and get back to my Friday festivities. Anyway, if you watched my video, thank you so much. I really greatly appreciate it. It really helps. Everybody needs support somehow. And yeah, if I can get viewers, that's awesome. But I also want to know what I'm doing, like how I can improve. So, and I also want to be able to help students. So if you have a problem that you would like to see work done, please post in the chat and I will go to work on it. And if not, then I will just try to keep coming up with ideas to present so that I can work on getting better. And yeah, I hope everyone has an amazing weekend. And I will for sure be back on Monday, same time, same place. And so I look forward to seeing you all again. And I will go ahead and sign off there, and I'll say bye for now, and I will see you next time.